The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our 30 minutes of free training for SolidCAM Live. With me today, as always, is Kevin Rankel. Hey, Kevin.
Hey, how's it going?
So today, we actually got a part from one of our customers here. I think he's actually in attendance. It's Steve. Steve, I got your part here. I took a look at what you did, and what I wanted to do today is let's do a review of how Steve was able to apply HSM. And I think this is actually a good application of what he's done. It kind of goes against what we were talking about earlier about HSM versus HSS. We're going to go and do both on this part, and we'll see how it worked and how I normally would have approached this, but then how I actually think Steve's way actually worked a little better. So originally, Steve, if we open this up, was using helical machining in HSM. And usually helical, I save helical for anything that has a revolved nature to it or revolved feature. I don't usually think of helical or radial or any of those guys or spiral. I don't really think of those as ones to use on a part that has this kind of rectangular shape. But in this case, it actually worked out because the helical machining allowed him to get a toolpath that looks like this, where he actually used the boundary area to limit the travel to only within these areas. If we take a look at that constraint boundary, we'll see what he did. So user defined boundary, and he selected the edges of each of those pockets, meaning that the toolpath is constrained to be inside of those areas there. Pretty much each one of those pockets bounded by the center, and then he's applying a helical machining with a step down of the helix of 10 thou, and then a ramp angle of 5 degrees, incline milling. And then the rest of this is just limiting the travel of the tool. And then we get something that looks like that. Now with this, you get those helical entries. You get a helical toolpath that goes around that post like that. And that's pretty much where I would have just applied helical or spiral or any of those kind of guys if I'm looking to just do that post like that. But because it was the boundary was including this pocket, it actually ended up doing those corners for him. And that's actually important to show why this worked versus the way I would have normally initially attacked it didn't work. And I'm going to come back to this corner when I show you what I would have preferred to do. But let's take a look at the overall part. So with those 5 constraint boundaries, we actually did, or actually Steve did, all 5 of those sections. What I would have done to reduce the amount of work, it's not a lot, but reducing the number of clicks, because again, that's another thing that we always look at for optimizing your just programming time, is I probably would have applied exactly what he did. So this is actually just a save and copy of what he did, but with the constraint boundary of just the first pocket. If we take a look at that, actually first pocket, like on that side. So you can see that highlighted in purple. I would have just said only do that area there and then added the transform. We talked about transforms pretty recently as well. And you'll see in the transform I've done here, I just told it in the Y direction to repeat it 5 times with the distance of 1 3/4, and that happens to be the distance between those pockets. And because this is transform, I'm basically just copying that toolpath. So I noticed there's a repetition there, and I used it. But between the two, pretty much they do the same thing. We got that one, and we got that one. So they almost do the same thing. Maybe a difference in some of the retractions and whatnot, but ultimately it does the same thing. Same tool, same toolpath, whatnot. But like I said, usually HSM, I look at it as applying it to an overall solid. So looking at this, there's nothing really here that makes me think of using HSM because these are pretty simple surfaces. There's just that surface, and maybe just these corner surfaces. There's a little bit of corner there, but easily something I can go around and click on individually for something like HSS. And that would have been my initial reaction. So let's see what would happen if I used HSS on this. I ended up using, as an example, morph between boundary curves. So those particular surfaces there. So again, HSS is a very targeted toolpath. I had to specifically say I want to do those surfaces. So already one, basically, I'm not going to call it a drawback because I'm specifically trying to do helical right on that post there. But in the HSM way of doing it, it looks at the overall solid, and luckily helical machining actually worked on all those faces. But otherwise, it would have worked as well. So HSS is a good overall, whereas here HSM happened to actually work. But there's nothing about this that makes me think HSM. So that's why I wanted to show HSS on this. I chose the top curve there and the bottom curve there. So I'm basically just saying only apply the toolpath to that. If I tried to select those surfaces as well, like we saw with the previous toolpath, then I'm going to have to do things like in the link section, control my linkages between slices, my gaps along cut. The toolpath would look like a mess. So with HSS, you're better off just targeting it to what you're looking to do. So in this case, we're doing just those surfaces there between those two curves. It's the same tool. My levels I can control, in this case, automatically with SolidCAM 2020. And I'm doing that 10th step down. In sorting, I have it set to spiral. So I'm going to get that same helical movement that we saw in the previous toolpath, in the HSM toolpath. But then from there, there's still more work to get this to be done. So HSM is good for skipping a lot of this sort of steps because it recognizes things from the solid. But the technology you usually use in HSM doesn't always apply to the overall solid. So again, that's another thing to just keep in mind with the fact that I'm doing all these extra stuff to focus it on there, but I'm going to get a toolpath that actually really focuses, really does exactly what I'm asking it to do. And if we take a look at what I had to do with link, I'm actually just getting it to go to the safety distance when it does retractions. And then the gouge check, I just had to make sure I told it not to crash into the floor. Because again, remember, when you use HSM, it recognizes the solid, recognizes the shape of the tool, so it does a lot of that internal gouge checking. With HSS, we have to tell it what's there and what to avoid. So if I just left it as is, my tool happens to be a bullnose. So that tangent point right there, just on the top of that corner rad, is what's going to probably try and stay in contact with that bottom edge of that surface. And in doing so, it would have gouged that surface. So I needed to add that gouge check. So I gouge check against that floor, and I basically just told it to retract along the tool axis so it doesn't gouge that, but it continues the tool path. If we take a look at just the tool path on that one, it looks like that. So not that dissimilar from the HSM, but I had to do all of that just to get it in there. But you can see that it's a nice smooth tool path, one entry, one exit. And from there, if I wanted to, I could do the transform as well. Let me just do transform, translate, matrix. In the Y direction, we'll say 5, 1.75, and it gives you that little preview to show you that you're in the right direction. So save, and you got all that. Okay. Let's look at how we did now those corners, and this is where you're going to see that major difference between HSM and HSS. So I'm just going to focus on that corner there.
And before we get too far there, Mark, I think the question comes up every once in a while when we're doing a transform on this, where is that measurement coming from? So what I like to do is, it's not the gap that's in between there, it's from that point, yeah, like that exact point to that exact point is going to be the number that you put in there. It's not the actual gap between the spacing, it's the total gap move over. So
yep, it's a good question. It comes up a lot. Yeah, I agree. It does come up a lot because transform is literally translating that or rotating that from one instance to the next. So if you were to do just the gap, you're asking it to just travel across that distance there, and that's not what you need. You need to take, when the toolpath starts from there, you want it to start from there as well. So that is a direct translation. So yeah, so exactly there. That's where I got that 1.75. It's just from that corner to that likewise corner over there. The only time you have to do that with rotate, translate, your fourth axis indexing. You need to know the exact amount you're moving it. The only time you can avoid that is when you use coordinate system transform. If you're going from one coordinate system to another, one part to another, then you just need to select the coordinate system. As long as that coordinate system is oriented the same on every part, then you don't need to know what distance those coordinate systems are apart, because now you're just translating by the max by the coordinate system. But let's take a look at the HSS. This is also a save and copy of that previous one. So I'm still doing it as a 10th step down. I'm doing it as a spiral progression, but you can see that it's a little different in terms of how it works. This one is more specific to the surface. So there's something about the surface that it thinks it needs to jump around a little bit. So I'm not sure what was going on with that part there. But what I wanted to focus on was the corner. So because this is driven right by the surface, this is a much more detailed, much more specific application of the tool. That is a 1/8 tool, but this corner rad wouldn't allow it to fit in there. You could see there, if you could see it on the bottom of my screen there, I have a just under a 61 thou radius, which is obviously much less than the 1/16 radius of my tool. So the tool actually can't fit in there. So what HSS is trying to do is trying to account for that. It's trying to fit in there as best as possible. It's giving me those kind of weird movements there just to see if it can touch all the bases without actually colliding with the part, because we do have a gouge check on in there. So difference between HSM and HSS, pretty visual right there. HSM just went in there with whatever arcs it could, fit it, and that's it. With HSS, it's trying to get very specific, trying to clean that up as much as possible, especially with the shape of my tool. But you can see it's generating some weird movements there just to get that done. But I was able to do the same sort of thing in 2 tool paths with some extra clicks. And sometimes this is what you would have to do, because your HSM toolpath would be trying to do everything of the solid in one go, and sometimes that's not going to work. You can't really apply one strategy, one technology to an overall solid or to a limited area like that. So hopefully that makes sense. This also could be translated if I want to. I actually could have translated both of them in one go, which is probably originally what I would have done. But this is a good example of HSS versus HSM. So any questions on that? Okay, no questions. I was gonna touch base with Kevin. Kevin, what do you think? Well, how would you actually do this?
Yeah, I was, to be honest with you, Mark, I was a little surprised that that HSM spiral turned out as well as it did. But, you know, kind of going forward, we do have one here.
Perfect. So Steve is actually asking the question. So with HSS, can you give it a 30 thou step over for the vertical and a 3 thou step over for the angle? And that's exactly why I probably would use HSS, because it gives me the ability to actually differentiate between the surfaces. Now in one toolpath, no, you can't actually give it that different step. In HSM, you could. In, I believe it's Kevin's favorite one of the, is it the hybrid constant Z, or is it the, which one is it that you like, Kevin?
Yeah, yeah, it's, boy.
Whichever one it is.
Yeah, I can't think of it offhand, but.
Whichever one it is in HSM, remember there's that angle limit. Let me open up one of these guys and we can take a look at it. So you can give it a different step over in the passes section. So there's this angle limit here. So if we were to do a constant Z combined with, let's say if we did constant Z combined with the helical, then in the constant Z portion, we could tell it to limit the analysis of the toolpath from 90 degrees, which is perfectly vertical, to just off of 90 degrees. So that only focuses on the vertical portion of the solid. And then it would do whatever step over we tell it in this section. And then once we add a combination of, let's say, in this case, we probably have to do something like constant step over or horizontal or something like that. Maybe not horizontal, but whenever you can combine it, then you can give it a different step over going over there. But you'd have to find the HSM that allows you to do basically what you're doing here. Helical doesn't have that breakdown. You can see here that helical only really lets us choose one step down, and we can only really analyze it in one way.
Yeah, when you get started these combination tool paths, you will get the option for the one to do a step down, as well as an additional for a step over. So like Mark was saying, you know, between 0 and 45 degrees, it would be a step over. And then for the step down would be from your 40 to 90 degrees.
Yep. And with the idea of breaking it up, then you can actually think in terms of not just HSS, but if this is purely vertical, this opens itself up to profile.
Yep.
I probably would do all the verticals with profile, and then with profile, definitely you can give it that 30 thou step over. And then in the HSS, when we do this 3D portion, I can give it that 3 thou step over. Okay, so this is the second question from Steve. So adaptive step down doesn't allow it. Adaptive step down actually is not that, as far as I understand. Let's get into
basically adaptive step down is set up for, let's say Mark has the toolpath set up to do 10 thou increments, but in total his height of his wall is at 18 thou. So it can't do that last additional pass in there, and it can't get down deep enough because we're telling it that we want it to step down by 10 thou. So by doing the adaptive step down, it will automatically insert additional passes in there to make sure we clean up that geometry.
Yep, exactly. So it actually adapts to the features. Very similar to what we talked about either earlier this week or last week. Adaptive, I think it's called adaptive step down as well, in turning. So if your step down is, like Kevin just said, if you're doing it in increments of 10 thou, but you have something that is at 18 thou, well, you can do that first 10 thou, but then that last 8 thou is not going to get covered. It's just going to be stepped over for the next 10 thou. So you're actually you're doing 10 and then 20. So to get that final 2 thou out of the way, you just do that adaptive pass. It's just going to do one more pass. So that's basically what adaptive step down refers to. So if you wanted to break up or do different step overs, it's a different toolpath, or it's a combo toolpath that allows you to do that kind of different step. So this goes back to probably one of the other things I always talk about, where if you do more work on the programming side, then you're getting a better part. You do less work on the programming side, less code or whatever. Yeah, if you do a quick program, then a lot of times you're going to have to do some adjusting or whatnot on the machining side. So this is one of those things where if we just said, okay, let's just apply an HSM and we're done, then we're getting this sort of thing where, well, you know, we didn't break up the step down, so it's not as good. We have to probably do it again or whatever. Here, if we put in the work of doing the toolpath on this one, toolpath on this one, toolpath on these ones, we get that independent control, and then we're not trying to do one toolpath for the entire thing. We're actually focusing it on this one with the 30 thou step down, this one with 3 thou step over, and then this one probably with a 3 thou step over as well. And let's just take a look at how you could do that with profile. Now, if there are any other questions, there is a questions panel. You can always put your questions in there. We'll get to it today if we have time. If not, it gets added to our script for the SolidCAM live classes, and we'll make sure to get to it in the future. So just to round out the rest of the time, I'm going to show you how I would do profile on this. But if there is any questions, please feel free to put the questions in there, either questions on this or anything else we've covered previously. So all I'm doing with profile is just choosing that top edge there, because this is a purely vertical wall. It could be the top, it could be the bottom, really doesn't matter. I'll go to Tool, Select. Let's use that same tool. So I'll go Tool 5. Levels. I'm just going to say highlight that 0, click on the top of that post. So we're going to make sure that we start from the top there, and I'm just going to take it all the way down to that point right there. So that's the end of the post there. Now I clicked on just that edge. That's not a flat edge. That's not a flat surface. That's not a point. That's not a vertice. So I'm not getting that associativity. That just means that this toolpath is going right down to that face there, to that edge, but not associatively. It's actually just taking that measurement. So tool side left, if you remember when I chose my chain, I made sure it was going in a clockwise direction. So that's going to generate climb milling. If I wanted that helical movement like we had before, I'll just put a step down of, in this case, we were talking about 30 thou. So there's our 30 thou. Depth type, I can set this to helical. So this actually just gives us a helical movement. That's a constant Z force on the tool, meaning it's going to probably be a little more accurate. And with each revolution of that toolpath, in this case, it's a nice circle, but it could just be whatever chain I've selected. With each lap that this takes, it steps down by that 30 thou. So that's how we get that helical motion. There's nothing in here about ramp angle or anything like that. That is just telling it to go with each lap, go down by 30 thou. And then my link, I like to use profile or HSS because you get more control over the lead in, lead out. So in this case, I can easily control this. Let's just put in another 30 thou in there, save and calculate. And we get a toolpath that looks like that. Simple lead in, constant progression going down. And I generated that flatness at the bottom there, like you saw back over here. Let's just go back to data, generate flat last step. So that's what that's doing there. So that cleans up that wall with a 30th step down. And then with that previous toolpath, I could actually, with this one, if I wanted to, I could just eliminate the use of that surface, maybe just generate a toolpath just for that surface there and get my 3,000 step over on just that. And include this as maybe a gouge check surface if I wanted to. And then just do that bit there with another toolpath. And then with this guy, because of the size of the tool, I probably would stick with HSS, maybe just trying to count for it. Or I would try maybe the HSM, but HSM Helical, I mean, it ended up working, so I can't really say anything against Helical. It sounds like Kevin was surprised as well, but my first inclination would be something more like Constant Z or Constant Z Hybrid, or 3D Constant Step Over, maybe to get that same sort of movement there.
Yeah,
but if you're looking at
3D corner offset.
3D corner offset, yeah. But this looks more like it's even more applicable for profile if the tool was on size, or if we could kind of, I mean, with that HSM, if we take a look at the Solid Verify, it's essentially what's going to happen anyway, regardless of if we follow that design or not. We're going to be leaving material behind in that corner because of the size of the tool. So the tool is only, the corner is smaller than the tool, so we're actually still leaving material behind there. So with that in mind, if we don't go back to the designer and get it to change or anything like that, if we want to just kind of go with what we have, then we could still use the tool. We can use profile. And again, we're getting near the end of the session, but just want to show you what I would do with this. So let's say we go choosing the inside edge of that fillet, because we need to get to that edge there to get flatness at least, right? So let's do that. So let's say that is our profile that we're going to follow, and we're going to do climb milling. So we're going to be on the left side of that chain. Let's just grab this tool. Tool 5, and I'm going to make note that this has a corner radius of 30 thou. Let me just double check something before that's a 60 thou. Okay, so what I'm about to do doesn't make sense, but I was going to say, let's say that has a 30 thou corner there, or if we had a tool that's on size. This probably doesn't apply too well to this, but I'm just going to show you this anyway because we're running out of time. Okay, let's go levels. Let's say we just go from there to there. And if my tool had the proper corner, actually, let's just put a tool in there that has proper corner just to show what I want to show. So let's just go tool, bull nose. This one can be, so tool 5 is a 1/8. So let's make this 1/8. So let's give this guy the corner rad we're looking for. Okay, so levels, top to bottom, technology. What I wanted to show here is that if I use that chain there, obviously the tool is going to try and stay inside that chain. But what I want to do is I want to extend the toolpath out a little bit so that I form that corner as I go around. Even though this is a bull nose, you can think of it like a shape tool. So what I'm going to do is I'm going to go over here to geometry, and I'm going to shift the toolpath outwards by the radius of the tool. So modify by minus 0.08 or 0.68. Take a look at that from the top view. My tool is larger than that corner rad, but we know that from my my radius that if I step up by that much, I'm actually right on the wall there. So I'm going to actually form that corner exactly as intended there, at least in that edge and that edge. And this corner is going to be the 1/8 size of the tool. Hopefully that's making sense. So save and calculate.
And maybe once you hop back in there, Mark, let's change our start point.
Oh, yeah, that too. You have that ability in the geometry section. So let's get back in there. There it is. So in addition to modify offset, I'm going to change the start point. So position percent of the whole chain. Let's just say we start at somewhere over there.
There we go.
Okay.
And that helps you guys
so
out so you're not starting right in that corner.
Yep, so I'm not starting right in the corner, and to eliminate any witness lines, let's put in an overlap, and we'll give ourselves a lead in, lead out, so we can see that overlap. We'll just go with that. So there's my overlap, so it eliminates any witness line. I'm starting on that line there, and what I want to show what that looks like is, let's say we just suppress all these guys. And then solid verify. Just bring the stock up to date. And again, the bullnose is a standard shape, but it still could be used like a shape tool. So if we take a look at my corner there, if I run this guy through, I get my corner. So I get my nice corner formed by my tool. In this case, you saw me make a tool that is on size, but whatever you've got there. And then this corner is formed by that tool. It looks like a nice, smoother looking corner. Hopefully that makes sense.
And for that little additional that was there, we could just do a clear offset. I mean, there's a lot of different things that we could do there, but this was just a last minute example.
Yep. I think we actually covered something like this previously. We could do HSS and then stock definition, and it would focus only on this bit right here.
Yep.
Yeah. So hopefully that works out. So any questions on this, anything else, you can always give us a call at the main tech line. You can also send us an email. I'm going to put my email in the chat section. You can use this email to send us your questions, your comments, your suggestions for SolidCAM Live. If you're looking for your own personalized training, you can use that email as well to email me and just let me know when you're free, day and time, and then we can schedule your personalized training session. We can do your own questions, your own parts. Let's say, for instance, if Steve wanted to just focus this on in his own training session, we could have done that. If you have any kind of proprietary issues or security issues with your parts, you can always get us something to sign, an NDA or whatnot, and we can make sure to keep that private. If you know anybody that can benefit from SolidCAM, send them our contact info or get them the contact, give them our contact info or give them our contact info back and forth. At the end of the day, I don't know what I'm saying. So if you put us in contact or they get in contact with us and they get into a demo, you get that $100 gift card. So that is going on until the end of the month currently. That is a SolidCAM Live promo. So if anyone gets into a demo from your own suggestion, then you get that $100 gift card. Outside of SolidCAM Live promo, I think we talked about it yesterday, that's a $50 card, right?
Yep.
Okay. Yeah. So either 50 or 100. Depending on how you got them in contact with us. If they go to sale, you get 20% of that sale. So that plus the initial demo finder's fee, that's a good chunk of money just for helping us out to spread the word of SolidCAM. Like I said, we're continuing this until the end of the week, end of the month, end of the week, every day at 2 p.m. If you'd like to see this more after July, just let us know in an email as well, and that gives us the go-ahead to continue going on. But for now, we'll be doing this every day at 2 p.m. Till tomorrow, we'll talk to you guys tomorrow. Stay safe, keep your family safe, keep busy. Have a good day.
See you guys.